Guided means path is fixed, and unguided transmission medium, there is no fixed path. So just the data can move randomly. So that are two types we have seen. Then we have seen types of the cable: twisted pair, then coaxial and optical fiber. So twisted pair looks like this, where the cables are twisted with each other and data is sent. Twisted twisting is done to avoid the external noise. Then next we have seen coaxial cable, which is used in TV mostly. It is again a protected by two or three layers, and from this inner conducting core the actual data is being transmitted. And optical fiber, it is mostly used in medical field, we have seen. So which is a very thin cable, and at the top of this cable the data is flowed. So these are the three types we have seen. Then we have seen transmission modes. So transmission modes are of three types: simplex, half duplex, and the full duplex. Simplex means a machine can only send the data and second machine only receives the data. So that is nothing but the simplex transmission. Half duplex, a machine can send the data and receive the data, but at the second time, the same machine can receive as well as send the data. So at the same at initial means at first time, the one machine can act as a sender and second machine can act as a receiver. So it is nothing but the half duplex. Then we have seen full duplex. So full duplex, where full duplex is where both machine can send as well as the receive data simultaneously. That is nothing but the full duplex. So up to this we have seen yesterday. Whether anybody is having any problem in this. If not, I'll move forward. Okay, I hope nobody is having any problem. So we'll start second with next slot today for today's lecture. So today, yesterday, I one person, one student, so asked me one question. So Jadhav, okay, Abhijit Jadhav, name of the student is Abhijit Jadhav. He has asked one question, that what is the importance of DCOM in cyber security? So I would like to answer that question. So cybersecurity is nothing but whatever internet we are using. So whether DCOM is having any role in that security or in that internet or not, so that we need to discuss. So yes, data communication or computer network is playing huge role in this cyber security, because whenever we send any message, it is important that message should be reached in a proper way to the receiver. So proper way in the sense that it should be error free, it should not be hacked, or it should not be modified at all. Okay, it should not be modified at all. So let's discuss one example. Suppose you want to buy some product. Okay, for example, you want to buy a dress from Amazon. So what we generally do while buying any product, we first uh, see, or we first research the reviews related with that product, correct? So while reviewing, suppose before visiting to the Amazon, someone has already hacked the site of the Amazon, and they have put a wrong reviews or bad reviews related with the product. So whether we will buy it? No. So if the proper security is not provided to the particular site or particular business, it may hamper the business use. So it is very necessary that whatever data we are using through internet, that should be secure. One case was happened related with the Sony company also. Someone has hacked the website and all the network of the Sony company, and they have stole all their personal data, which includes the personal details of employees, their salaries, how many hikes they are getting or not, everything. And due to this, lots of issues was occurred related with the Sony company. So here is the role of the data communication, that it should, or computer network, it should be more secure. See, today's world is totally a digital data world. We are playing with the internet in every our day-to-day life. We are having emails, we are having online banking, we are doing online shopping and lots of things. So while doing all these things, it is necessary that our system or our data or our network should be kept more secure, and for that purpose only we need to learn how data is transmitted, how it is being sent from one user to the another, whether my network is secure or not, whether my account is hacked or not. It should be known how I can recognize, so that all things we are going to learn. So that is the importance of data communication in cybersecurity. Okay, so I hope I have given the answer of Jadov.
Yes, ma'am.
Have you got the answer?
Yes, ma'am.
Okay. So let's start our next point. So next point is the transmission impairments. So the impairments or impairments is nothing but just a minute. Impairments. So transmission impairments are nothing but the obstacles. Okay, in short. So whenever a signal travels through the transmission medium, for example through wire or through or without wire, so which are not a perfect. So yesterday also I have told, no transmission is without error. There is an error in every transmission. Whenever we are sending the data, error definitely occurs. So this imperfection causes a signal impairments. Means what? When whatever signal is sent, that is not received exactly as it is to the receiver, due to these external effects on the signal, and this is called as a transmission impairments. So it means that signal at the beginning of the medium is not the same as the signal at the end of the medium. See, if a single bit is getting changed within a signal, the whole data or the representation of the signal will change. Suppose I'm sending the bit 101, but at the receiver suppose it is getting as 111, so it is totally different. So such obstacles or such changes are called as a transmission impairments. Whatever signal is getting generated for sending message, that is not matching with the receiving message, and this is called as a transmission impairments. What is sent is not what is received at the receiver side. So there are some consequences means cases. So for digital signal there may occur a bit error, as I told you. If the signal is digital, that is in the form of square waves, 1010 in that format, so impairments means it is nothing but the bit error. So one will be changed, one will be represented as a 0, 0 will represent as a 1. So that is called as a transmission impairments for digital signal. And for analog signal, impairments degrade the quality of the signal. Means signal is not matching with the original analog signal. So that is nothing but the transmission impairments for the analog signal. Now, there are three causes, or these are the three impairments generally occurs while sending the data from sender to the receiver for both the waves. See, the square wave, or we can say digital signal or analog signal. So, first is the attenuation, distortion, and noise. Distortion is also called as a delay distortion. These are the three impairments or the three causes of transmission impairments. First one is the attenuation, second is the delay distortion or only distortion, and third one is the noise. Okay, so let's see one by one what is mean by the attenuation. So attenuation is nothing but the loss of energy. Loss of energy. So what is this loss of energy? Suppose I'm sending the data from, or there are two nodes A and the B, and the distance between these two nodes is, for example, 1 kilometer. So the data can be sent properly, no doubt. But suppose I'm increasing that distance up to 50 km, and I'm using the same medium to send the data. I'm sending the same data. So if I increase the distance between the two nodes while sending this data, the energy or the data is getting lost in between, and this effect is called as an attenuation. करेक्ट. जर सपोज मी दोन नोड मधलं डिस्टन्स कमी असेल तर माझा डेटा प्रॉपर जाईल, त्याच्यामध्ये डाऊट नाही. बट जर मी तुमचं डिस्टन्स आहे दोन नोड मधलं ते इन्क्रीज करत गेले तर माझा डेटा काय होईल, लॉस होईल ॲज आय एम इन्क्रीजिंग द डिस्टन्स, अँड दिस इज कॉल्ड एज एन अटेन्युएशन. Okay, so when a signal, simple or composite, travels through a medium, it loses some of its energy in overcoming the resistance of the medium. Means through medium, whatever it is using to send the data, if the distance is getting increased, it loses its energy, or we can say it loses its data. That is why here is an example. That is why a wire carrying electric signal gets warm after a while. You may have experienced if you do or you if you are charging your mobile. Okay, after if it is getting means after 2 or 3 hours we may get a charger in a warming condition. Also our laptop charger also, after some time it getting warm. So that is nothing but the attenuation. And why it is happening? Because the whatever signals are traveling or electric energy is traveling, it is getting impaired due to some external effects or due to over use of that particular medium, and it is called as an attenuation. So some of electric energy in the signal is converted to the heat, and that is the effect of the attenuation. So, how to overcome this attenuation, whether we kept it as it is? No. So, no error, no any effect should be kept as it is. It is clear that, or it is decided, or it is true that we cannot avoid this error completely. कुठलाच इफेक्ट किंवा कोणतीच एरर कम्प्लिटली अवॉइड होऊ शकत नाही कोणत्याच कंडिशन मधली, ज्यावेळेस आपण डेटा ट्रान्समिट करत असतो त्यावेळेस. बट इट इज नेसेसरी दॅट द इफेक्ट ऑफ दॅट एरर or that effect of that particular condition should be reduced. So to control this effect on your transmission medium, some amplifiers are used to amplify the signal. To amplify the signal means to control the effect of this attenuation on your signal. So these amplifiers are used. Now, what is this amplifiers? See the diagram. So this is my original signal at some point 1. This is original signal. Now, when this signal is getting transmitted through this transmission medium, may be possible that this signal will get changed. So these amplifiers are used after every some distance to amplify this signal. So you can see here attenuated means this signal is getting changed at point 2. This is original signal and this is affected signal. Okay, at point 2. So whenever this signal is getting affected and because of any reason, this signal is amplified with some amplifiers. What are the amplifiers? Next slide I'll explain. And as a result, we will get a signal which is definitely not same as the original signal, but which will definitely match up to some extent to the original signal. क्लिअर. जो काय मला रिसिव्हर साईडला सिग्नल मिळणार आहे डेफिनेटली एक्झॅक्टली इट विल नॉट मॅच टू द ओरिजिनल सिग्नल, होणार नाही, बिकॉज सिग्नल मध्ये चेंज झालेला आहे. डेफिनेटली त्यातले काहीतरी बिट चेंज होतील. बट ऍट द रिसिव्हर साईड whatever signal I am getting that will be same, means up to some extent we can say 99% will be same as a original signal, and that is the use of the amplifiers. If I have not used these amplifiers, the amplifiers use केले नाहीत, तर काय होईल, this original signal and the receiver side signal will be totally different. हे काय असतील पूर्णपणे डिफरंट असतील. सो टू मॅच द सिग्नल ॲट द रिसिव्हर साइड दिस amplifiers आर used. So that is the use of the amplifiers. Now which type of amplifiers are used? How amplifiers works? So different forms of amplification introduce more or less noise into the signal. So there are lots of types of the amplifiers are there which are used to get the original signal. In computer network, amplification typically includes logic for noise reduction to ensure the underlying message data does not get corrupted in the process. Okay, so amplification कशासाठी यूज होतं तर generally what it does, it just reduce the noise and it ensures that the message whatever is sent between this transmission medium, it should not get corrupted. So that is the use of the amplifiers. Now this is one example of the amplifier, that is nothing but the network repeater. It is one type of device which works same or which works as a amplifier between the two nodes. Okay, network repeater, it is a device typically integrate a signal amplifier into their circuitry. The repeater works as an intermediate between two message endpoints like this. Okay, here these repeaters are used and which is working as an intermediary between point 2 and point 3. It receives the data from the original sender, processes it through the amplifier, and then transmits that stronger signal forwarded to its destination. So what it does, it just receives the data from this point to process that data or amplifies that data and send the data back to the destination so that the data can be same as the original data. So that is the work of the amplifiers. So in short, what is the work of the amplifiers? Amplifiers typically used as a boosting energy for a signal. Okay, boosting energy like this. You can see here attenuated म्हणजे काय असणार आहे तर signal is getting weak. इथे energy loss झालेली आहे त्याची. So whenever we are using these amplifiers, it getting again its original position.
Excuse me, ma'am.
Yes, yes.
PPT is not visible.
What?
PPT is not visible.
Okay. Now is it visible? Is it visible?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay. Okay. So that is the use of the amplifiers, right? So it works same as a boosting energy for a attenuated or the weaker signals. Now, how the attenuation is measured? So how we can know that whether the signal is attenuated or whether the signal is or the energy of the signal is lost or not. So to measure the attenuation or effect of the attenuation, this decibel unit is used, dB unit. And the formula or how we can measure the attenuation is dB is equals to 10 log to the base 10 P2 by P1. This is the formula to measure the attenuation. So what is P2 and P1? So P1 is an input signal and P2 is an output signal. Input means original signal which is sent by the sender, and P2 means the signal which is received at the destination site. So that is the formula for calculating effect of attenuation on your signal. dB is equals to 10 log to the base 10 P2 by P1. This is the formula. So everybody understood what is attenuation? We are going to see some of the examples on this. Attenuation means what? Yeah, attenuation means what? Loss of energy. ज्यावेळेस डिस्टन्स इन्क्रीज होतं दोन नोड मधलं त्यावेळेस काय होतं, सम एक्सटर्नल इफेक्ट्स असेल किंवा जास्त डिस्टन्स आहे त्याच्यामुळं डेटा कॅरी होताना किंवा सिग्नल कॅरी होताना काय होतं त्याच्यामध्ये चेंज होतो आणि रिसिव्हरला सिग्नल ऍज इट इज मिळत नाही. तर त्याच्यासाठी आपण ऍम्प्लिफायर्स यूज करतो इन बिटवीन. जेथे सिग्नल तुमचा चेंज झाला तिथं ऍम्प्लिफायर यूज करून त्याला ओरिजिनल पोझिशनला आणायचं. Right, so that is the use of the amplifier. And attenuation is one type of impairment which is happening during transmission of your data, and it is always measured in a decibel, and the formula is 10 log to the base 10 p2 by p1, and p2 is output signal, p1 is input signal. Now next, this is, let's see one example for this. Suppose a signal travels through a transmission medium and its power is reduced to one half. What is the sentence? Suppose a signal travels through a transmission medium and its power is reduced to one half. Means whenever signal is reaching to the destination, the power of that signal is getting one half of the original signal. Right? In this case, attenuation or loss of power can be calculated as, what will be the loss of power? So this is the solution. How it is calculated? What is given here? Power is reduced to one half. It is given power is reduced to one half. That is nothing but at the receiver side, this P2, that is output signal, is one half of the input signal P1, right? And from this we have to calculate the effect of the attenuation. So what is this? dB is equals to 10 log to the base 2 P2 by P1. So P2 is 0.5, means one half of the P1, 0.5 of P1 divided by P1. So whenever you will solve this example, you will get minus 3 dB. So in this case, when the signal is half of the original signal, the loss of the energy is minus 3 decibel, or we can say in this loss of the energy, minus and plus are considered the same, means there is 3 decibel loss of energy. Clear? Easy. जे काही दिलेलं आहे त्याच्यावरून फक्त आपण काय केलं, किती लॉस झालेली आहे एनर्जी ह्या पर्टिक्युलर केसमध्ये ते कॅल्क्युलेट केलं. बिकॉज इट इज गिवन, ज्यावेळेस सिग्नल रिसिव्ह होतो त्यावेळेस काय आहे की जो सिग्नल आहे तो वन हाफ झालेला असणार आहे ओरिजिनल सिग्नलचा. मीन्स रिसिव्हर साईडचा सिग्नल आपला कोणता आहे? अकॉर्डिंग टू दिस साइड, दिस फॉर्म्युला P2. So P2 is equals to half of the P1. So when we keep the values in this formula, we'll get the answer as a 3 dB. It means that in this particular example, there is a loss of 3 decibel energy. Okay? Now, we'll see one more example on this. Now, you have to solve this example. I told you already that you should keep your calcs with you. And now tell me the answer for this. I'll read the example. A signal travels through an amplifier and its power is increased 10 times. Okay. In earlier example, it is getting lost or it is getting decreased. But in this case, it is getting increased. Because at the receiver side, the whatever signal is getting, that is 10 times of the original signal, which means P2 is equals to 10 P1 we are getting. Now we have to calculate same. In this case, the amplification, which is gain of the power, can be calculated as, use same formula. The formula is, just write this formula. First write this formula. dB is equals to 10 log to the base 10 P2 by P1. Right? And solve this example. And tell me the answer. What will be the answer? Expected that
10
everyone
dB.
is, sorry?
10 dB.
Yeah, it is exactly. Everyone has solved?
10 dB.
Yes, 10 dB. Others? Remaining students, please give me answer. Are you getting the answer?
Yes, ma'am.
So what is the answer? 10 dB. Okay, okay. Anybody is not getting the answer, please let me know. Yes, 10 dB. Most of you have solved. Good one. Okay, so I'll show the solution. Those who have not solved, please see. So as I told you, power is increased at 10 times, means P2 is equals to 10 time of P1. Same formula we have to use, and when you will solve this, you will get as a 10 dB. So obviously it is getting 10 times means increased. So there is a gain of energy of 10 dB. That is the answer for this. Okay, so any doubt in attenuation? Any doubt?
No, ma'am.
No, everyone understood. If anybody is having doubt, you can ask, please. I hope everyone has understood because most of you have solved the example. Good. Then next, the second effect or second transmission impairment is the distortion. First was the attenuation, second is the distortion, which is also called as a delay distortion. Delay distortion. What is mean by distortion? So distortion means the signal changes its form or shape. Okay, that is nothing but the distortion. I'll show you the diagram. So this is the original signal, and at the receiver side the signal is getting changed. This is my original signal, and at the receiver side the signal is getting changed, means its shape or the form is getting changed at the receiver side. That is nothing but the distortion. Okay, so distortion means the signal changes its form or shape. Distortion can occur in a composite signal made up of different frequencies. So it can be in any signal, distortion can occur. Each signal component has its own propagation speed through a medium, and therefore its own delay is arriving at the final destination. Now, why this distortion is happening or why the shape of the signal is getting changed at the receiver side? The reason is this one, because propagation delay or propagation speed means what? Every signal travels through its own speed. प्रत्येक सिग्नलचा मीडियम थ्रू ट्रॅव्हल होण्याचा एक स्वतःचा स्पीड असतो आणि त्या स्पीडनं तो ट्रॅव्हल होतो. त्यामुळं काय होणार आहे तर रिसिव्हरच्या साईडला ज्यावेळेस तुमचं सिग्नल जाणार आहे त्यावेळेस जे सिग्नल्स येतील किंवा जो डेटा येणार आहे तो कमी जास्त प्रमाणात मी स्पीड नुसार तो व्हॅरी होईल. अँड दॅट इज द रिझन दॅट ऍट द रिसिव्हर साईड द शेप ऑफ द सिग्नल गेटिंग चेंज्ड. Right? So reason of distortion is what? Each signal component has its own propagation speed. प्रत्येक सिग्नलच्या कंपोनंट मध्ये म्हणजे 1-0 जे डेटा असणार आहे तो त्याचं स्वतःचं स्पीड असणार आहे. त्यामुळे रिसिव्हर साईडला कोण आधी पोहोचेल कोण नंतर पोहोचेल असं होईल. त्याच्यामुळं जो सिग्नल आहे तो सेंडर साईडला जो आहे तो रिसिव्हर साईडला सेम राहत नाही. दॅट इज नथिंग बट द डिस्टॉर्शन. So differences in delay may create differences in shape if the delay is not exactly the same as the period duration. Okay, so whatever I have explained. So differences in the delay. Delay means what? वेळ लागलेला आहे. May create differences in phase if the delay is not exactly the same as the period duration. Means हा जो सिग्नल आहे तर प्रत्येकाचा जर डिले सेम नसेल, इट इज ओके दॅट 1-0 सपोज 5 बिट्स आहेत 1-0-1-0-1 आणि प्रत्येकाला सेम डिले आहे 1 सेकंद आहे. सो ते प्रत्येक जण एक सेम फ्लोनं ट्रॅव्हल होतील आणि डेस्टिनेशनला सेम सिग्नल मिळेल. पण जर त्यांच्या डिले मध्ये पण डिफरन्स असेल, 1 विल ट्रॅव्हल 1चा डिले आहे सपोज 1 सेकंद आणि 0चा डिले आहे सपोज 2 सेकंद. So obviously there is a difference will occur at the receiver side. That is nothing but the distortion. So in other words, signal components at the receiver have phases different from what they had at the sender side. The shape of the composite signal is therefore not the same. Okay, so that is the reason for the distortion. And here is an example. So you can see here, this is original signal. You can see this is original signal and this is this. And at the receiver side, okay, this signal is getting changed. It is starting from this point and then it is varying. But at the receiver side, it is starting from this point and then it is getting varied. So obviously this small change will occur the change in a signal. What is said here is that at the receiver have phases different from what they had at the center. Now yesterday we have seen the concept of a phase. What is mean by phase? फेज सिग्नल तीन गोष्टींवरती डिपेंड असतो अँप्लिट्यूड देन फेज अँड फ्रिक्वेन्सी हे काल सांगितलं होतं व्हॉट इज मीन बाय फेज सो फेज इज अन हा यस
Y axis से केलेला angle.
yes angle right so it is an angle so you can see here the angle is getting changed at the receiver side and that is the reason that at the receiver side the signal is not matching. Am I clear? So this is called as a distortion or delay distortion, which is one type of effect which is happening on the signal. Okay, then समजलं second impairments distortion. Distortion means what? Original signal match होत नाही रिसिव्हर साइडला. कशामुळे होत नाही तर त्याच्या फेज मध्ये चेंज होतो. आणि हा चेंज कशामुळे होतो तर प्रत्येक कंपोनंट जो आहे सिग्नल मधला तो स्वतःच्या स्पीडने ट्रॅव्हल होत जातो आणि ते स्पीड एकमेकांच्या सोबत मॅच न झाल्यामुळं रिसिव्हर साइडला हा डिफरन्स जनरेट होतो. दॅट इज नथिंग बट द डिस्टॉर्शन. ठीक आहे. सो दिस इज द सेकंड इम्पेअरमेंट. अँड the third one, noise. So noise is nothing but it is an unwanted signal which interferes with the original message signal and corrupts the parameters of the message signal. What is mean by the noise? It is unwanted signal. Means whatever original signal we are having, some extra uh, data or extra effects is get added into the original signal, and due to this our original message is getting corrupted, and that is called as an noise. Okay, so noise is an unwanted signal which interferes with the message signal or original message. So that is nothing but the noise. This alteration in the communication process leads to the message getting altered. So obviously, if the message is getting noisy, this what there are some extra bits are get added into the original data. So obviously, your original message is not same as or it will not be same at the destination side. So it is most likely to be entered at the channel or at the receiver side. So that is nothing but the noise. It is the one example of the noisy signal. You can see here. There is no fixed pattern available for the noisy signal. There is no data we can get same as the original data in case of the noisy signal. So from this diagram, we can clearly say that noise is some signal or it is a type of signal which has no pattern and no constant frequency or no amplitude. Okay, there is no fixed pattern. कुठे दिसतोय का fixed pattern? No. Right? Then no constant frequency. कुठलेही कॉन्स्टंट फ्लो न तो व्हॅरी होत नाही किंवा कोणतंही कॉन्स्टंट अँप्लिट्यूड इथं मेंटेन केलं जात नाही. दॅट इज नथिंग बट द नॉइज सिग्नल or noisy signal. So it is quite random and unpredictable. We cannot know or we cannot predict anything will be achieved through this particular signal at the receiver side. Measures are usually taken to reduce it, though it can't be completely eliminated. We can't completely eliminate any noise occur during the signal, but we have to reduce it up to some extent. Okay, these are some common examples of the noise. These are the examples of the noise. So, for example, his sound in the radio receivers. ठीक आहे, रेडिओची फ्रिक्वेन्सी जर मॅच झाली नाही त्यावेळेस आपल्याला एक साऊंड येतो. सो दॅट इज अगेन अ टाइप ऑफ नॉइज. Then burst sound emits of the telephone conversation. Also flickers in the television receivers or crosstalks. Or maybe you have experienced if suppose I have connected my laptop and I have started Google Meet on my laptop as well as mobile, same meeting. So it creates one noise. So that is again a type of the noise which is occurring during the communication. So there are lots of noise. Crosstalk is there. Okay, crosstalk, then cross connection. So all these are considered as a noise which is happening during the communication. There are some types of the noise are available. First one is the thermal, then induced, then crosstalk and impulse. These are the types of the noise. Types in the sense which are mostly happen due to some specific criteria. That is nothing but the types of noise. We can have number of noises, internal noises, there external noise. If you search on the Google types of the noise, you will get list of the noises which are happening during the communication. But these are the four broadly decided noise which are generally occur during the communication. So first type of the noise is the thermal noise. So thermal noise, so it is a random noise of electrons in the wire which creates an extra signal. Okay, so during the wire or the transmission medium which creates an extra signal through the electrons, that is called as a thermal noise. It is also, or the second name for this noise is white noise, thermal noise or white noise. The second is the induced noise. So it is generated from motors and appliances, which are the in which these devices act as a transmitter antenna and medium as a receiving antenna. Hence, this induced noise is generated due to some appliances or due to some resources which are used to send the data or for the communication. Then third type of noise is crosstalk. So crosstalk noise is when one wire affects the other wire. Okay, so if the one wire or the effect of the one wire is getting affected to the other wire, then it is called as a crosstalk. And last one is the impulse noise. Okay, impulse noise is a signal with high energy that comes from the lighting or the power lines. Impulse noise, I'll show you the example. See, suppose this signal or here, let it be. So impulse noise means what? Suppose this is one signal. Okay, it is flowing like that. And suppose it is having the constant flow. And at some point, sudden peak is happening. Means like this or like this. Sudden peak. एका कॉन्स्टंट फ्लो न तुमचा सिग्नल फ्लो होतोय, पण एखाद्या सर्टन पॉइंटला एकदम खूप जोरात द सिग्नल चेंज झाला ऍट इट हायेस्ट पीकला, तर जर तो पोहोचला तर सच नॉइज इज कॉल्ड एज अन इम्पल्स नॉइज. आणि हा कशामुळे जनरेट होतो, तर एक्सटर्नल लाईट इफेक्ट मुळे तुमच्या सिग्नल वरती इट गेट जनरेटेड. सो दीज आर द फोर टाइप्स ऑफ द नॉइसेस: thermal noise, induced noise, crosstalk, and impulse noise. These are the four types of noise which are generated. Am I clear? These three types of the impairments: attenuation, distortion, and the noise. Attenuation means loss of energy. Don't get jumbled in these three, because question will be asked as write a note on or explain the transmission impairment. So you have to explain all these three. Attenuation means loss of energy. Distance जास्त असेल तर सिग्नल लॉस होतो, रिसिव्हरला मिळत नाही ऍज इट इज, त्यासाठी ऍम्प्लिफायर्स यूज करायचे. अटेन्युएशन. डिस्टॉर्शन मीन्स ओरिजिनल सिग्नल मॅच होत नाही रिसिव्हरकडं. कशामुळे मॅच होत नाही तर त्याच्या फेजमध्ये चेंज कॉन्स्टंटली फ्लो होत नाहीत. प्रत्येकाचा फ्लो होण्याचा जो रेट आहे that is totally different, and due to this the distortion is occurred. And noise means original signal is affected due to the extra signal, or the unwanted signal is get added into the original message signal, and receiver side will not get the original message. There is no constant flow in case of the noise for the signal. No constant frequency is available. No constant amplitude will be maintained in case of the noise. Four types of the noise: thermal noise, then impulse noise, crosstalk, and last one is the which one? Induced noise. These are the four types of the noise. Any doubt? Everyone has understood?
Yes, ma'am.
Others? समजले सगळ्यांना?
Yes, ma'am.
Yes,
Yes.
ma'am.
Yes,
Anyway,
ma'am.
sharing.
Yes, ma'am.
Okay, okay, fine. So these are the transmission impairments we have seen. Then next, depending upon this noise, okay, there is one concept available, or concept we have to see, which is used in next point, or which is required in next point. That is why I'm covering this. So it is called as an SNR. So SNR stands for signal to noise ratio. Signal to noise ratio, the full form, signal to noise ratio. So what is this SNR? Is nothing but to measure the quality of the system the SNR is used. Okay, whether the noise is added, or whether noise is present in the signal or not. If it is present, what is the effect of that particular noise in a on signal? To measure all these things, SNR is used, which is nothing but the signal to noise ratio. Okay, so what it indicates? It indicates the strength of the signal with respect to noise power in the system. Okay, means in presence of the signal, in presence of the noise, what, how much signal is powerful, whether it can carry the data or not. That is decided by using SNR. It is the ratio between the two powers, means sender and the receiver, and it is usually given in the decibel and referred to as SNR dB. It is represented as SNR dB and measured in a decibel. We have examples, at that time you will get understood. So SNR is nothing but the signal to noise ratio, and it is used to understand if noise is present within the signal, whether that signal is capable to carry the data or not. That is the only concept, and it is represented by using SNR dB, and its unit is decibel. So that is the small concept I want to explain. Now it is more important on this capacity of the channel. The questions are asked in your question paper as well as in GATE examinations also. At the last of the chapter, means whenever our chapter will over, I'm going to cover all the examples through GATE question paper related with all these concepts. So channel capacity of channel is very important because most of the questions are asked in GATE examination also on this particular point. So let's see what is capacity of a channel. So capacity of channel, it means that capacity of a transmission medium. Channel means wire or link. So what is the capacity of that channel? How much data it can carry or it can hold during the transmission. That is nothing but the capacity of particular wire or that link. So capacity is number of bits the transmission medium can hold, right? So a wire or a link, whatever is used to transmit the data between two nodes, how much bits or how much data it can carry within its transmission, that is nothing but the capacity of that wire. For example, the transmission medium is operating in its maximum capacity. Then At that time, the number of bits it is holding is called as the capacity of the transmission medium. Okay, means ट्रान्समिशन मीडियमची कॅपॅसिटी काय असणार आहे, मॅक्झिमम किती तर बिट्स हँडल करू शकतो, दॅट इज नथिंग बट कॅपॅसिटी ऑफ दॅट ट्रान्समिशन मीडियम. Now, the channel capacity is important consideration in data communication. That is how fast we can send the data in bits per second over a channel. Means capacity of channel is measured in bits per second. And what it does, it decides how fast we can send the data. Because obviously, depending upon the capacity of the channel only, we can send that much data. If it is low, obviously our data will not be sent fast. If it is low, capacity जर त्याची low असेल तर data fast जाईल का? No, it is not possible. So capacity of channel decides how fast we can send our data during the particular medium. Okay, so the maximum data rate limit over a medium is decided by using three factors. So what will be the rate, or what will be the capacity, or what will, in which flow the data can be sent? It is decided by using these three factors. First one is the bandwidth, then signal levels, and third one is the channel quality. We'll see one by one. What is mean by the bandwidth? So bandwidth describes the maximum data transfer rate of a network or internet connection. So what is mean by the bandwidth? Maximum data transfer. किती होईल maximum data through the internet connection or through network or through wire, whatever we are using. So it measures how much data can be sent over a specific connection in a given amount of time. In 1 second, in 2 seconds, how much data, how much maximum data can be sent to the receiver or through the medium. That is nothing but the bandwidth. So that is the first term. The second is the signal levels. Now, what is this signal level? It is nothing but which level is used to send the data and how it is calculated. I have given some examples over here. See here. So if level is 1, it means that at a time either 1 or 0 can be sent. If it is 1, so at a time either 1 or 0 can be sent. 1 or 0 data, binary data can be sent. Suppose this level is 2, then combination of 2 bits can be sent. For example, this level is 2, it means that 2 raised to n, that is 2 raised to 2 is equals to total 4 bits can be sent. But these 4 bits are the combination of these two, means 11001001. Combination of 1 and 0. This much data can be sent. And suppose if the level is 3, then total 8 bits can be sent and the combination will be 1110000101 and so on. So total 8 bits can be sent. This is called as the signal levels. It is very important. Remember, signal levels means what? जर suppose signal level 1 आहे तर त्याचं meaning काय असणार आहे? At a time either 1 or 0 can be sent. If it is 2 means what? Total 4 bit data जाईल, पण तो डेटा कसा असेल? कॉम्बिनेशन मध्ये असेल. कसा असणार आहे? 110010 likewise. So this 2 is nothing but this 2 1 2 1 2 likewise. पण किती जाणार असा डेटा? तर 2 raised to 2. This 2 is nothing but this one. So total 4 bits can be sent. Similarly, 2 raised to 3, 8 bits, but combination will be of 3. Suppose it is 2 raised to 4. The combination will be 1111 likewise. So that is nothing but the signal levels. Okay, and the third one is the channel quality. So it depends upon how much noise is available in the channel. If noise is low, it means that we can carry maximum data. If noise is high, it means that there is no chance of sending maximum data. जर नॉइज खूप सारा आहे तर डेटा जाईल का? नाही जाणार. टीव्ही वरती खूप सारे ब्लर दिसते, म्हणजे आपल्याला ओरिजिनल पिक्चर दिसेल का? नाही दिसणार. कॉन्व्हर्सेशन मध्ये खूप सारा आवाज येतोय, एक्सटर्नल इफेक्ट्स खूप आहेत. माझा ओरिजिनल मेसेज पोहोचेल का तुमच्यापर्यंत? नाही पोहोचणार. सो डिपेंडिंग अपॉन द नॉइज अवेलेबिलिटी इन अ चॅनेल, the quality of the channel is decided. So these are the three factors with the help of which are used to decide the channel capacity. These are the three measures. Now, these are three used, but how exactly channel capacity is measured? So there are two formulas we need to use, and these two formulas are implemented, or these are given by two scientists. First one is the Nyquist and second one is the Shannon. And these formulas are known as Nyquist channel capacity formula and Shannon channel capacity formula. So they both have decided the capacity of the channel depending upon the noise. Right. So Nyquist has designed the capacity of the channel formula for noiseless channel. Nyquist has considered that there is no noise available during the transmission. कोणताच एक्सटर्नल इफेक्ट झालेला नाही त्या पर्टिक्युलर सिग्नल वरती, असं अज्युम करून नायक्विस्टनं कपॅसिटी फॉर्म्युला डिझाईन केलेले. अँड शॅनन कपॅसिटी फॉर्म्युला हॅज डिझाईन फॉर नॉइझी चॅनल. मीन्स शॅनन हॅज considered that there is noise available within the channel, or within the transmission medium, and then what will be the capacity of the channel, that is decided. So these are the two scientists who decided that what will be the or how to decide the quality of the channel. Two scientists, Nyquist and Shannon. We will see one by one. So listen carefully. It is, these two concepts are important. Okay, it is very easy, just we need to consider and we need to relate the things whatever we have seen up till now. So Nyquist capacity formula is, as I told you, it is considered for noiseless channel. Means there is no noise available in a channel, it is assumed. Now what is the capacity formula? If the levels of a signal increases, then probability of an error occurring also increases. This is the assumption of a Nyquist. What it says, if the levels of signal increases. Now what is this levels? That already we have seen, this one, right? If suppose these levels of signal is getting increased, then there is a possibility of error occurring, that is also getting increased. That is the first assumption. But why this will happen? Why? Yes,
Some of the students are unable to see PPT.
someone is presenting, Poonam Pandare. You are presenting your screen. That's why my screen is not getting. Please don't share anything. Now is it visible?
Yes, ma'am.
Okay. So what I told, if the levels of the signal is increased, then error, probability of error occurring is also increased. But why this is happening? So there is a reason. See here. This is, for example, this is my channel. Okay, this is my channel. Through this I am sending the data. Through this I am sending the data. Now for example, the capacity of this channel is, suppose it can carry maximum 4 signals at a time, or the level of the signal maximum it can carry is 4. Now what will happen? Suppose I am sending, or the level of the signal is what? First one, it is 1. चॅनल मधून सिग्नल जायची फर्स्ट लेवल काय 1 आहे. मीन्स व्हॉट, ऍट अ टाइम काय जाईल, माझा डेटा कसा जाईल, 1 जाईल और 0 जाईल ड्युरिंग दिस चॅनल. Correct, 1 or 0. So if it is 1, level 1 असेल, it is very easy or data can flow very easily during this channel. Suppose I have increased the level of signal to 2. So data कसा कॅरी होणार आहे 1 1 0 0 1 0 0 1 likewise. सो अगेन काय झालं ह्यातला डिस्टन्स आहे ते कमी मेंटेन झालं. सिमिलरली सपोज आय हॅव इन्क्रीज्ड द लेवल टू द 3. what will happen again 1 1 1 1 0 1 0 0 0 हे सगळं डेटा इथून फ्लो होईल. इट इज 4 1 1 1 1 0 0 0 0 लाईकवाईज. मीन्स जसं जसं मी हा डिस्टन्स किंवा लेवल वाढवत जाते तसं काय होतं तर ह्या चॅनेल मधला डिस्टन्स कमी होत जातो. आणि that is the reason if I increase the signal levels the error will definitely occur, because if the levels are increased it means that number of bits are coming during this channel are very or they are coming simultaneously, and it may possible that they will get crash with each other. करेक्ट. जर मी हे लेवल्स वाढवते म्हणजे काय होते ऍट अ टाइम माझे 4 झिरोज येत आहेत, ऍट अ टाइम माझे 4 वन्स येत आहेत, ऍट अ टाइम माझे 111 0 4 बिट्स येत आहेत. मग जर ह्या चॅनेलची कपॅसिटी जेवढी आहे त्याच्यामध्ये जर मी मॅक्सिमम डेटा पुट करायला लागले तर काय होणार आहे माझा डेटा एकमेकांच्या सोबत क्रॅश होणार आहे आणि त्याच्यामुळं एरर ऑफर होणार आहे. करेक्ट. सो it is considered that if levels of the signals are increased definitely error will get increased. That is the reason. Have you understood why error will get increased? जर सपोज 1 असेल इझी फ्लो होईल कारण डेटा काय असणार आहे माझा 1 आणि 0. सो खूप सारा स्पेस आहे त्याच्यामधून एक बिट ऍट अ टाइम कसाही जाईल. 2 केला कॉम्बिनेशन असेल 1 1 0 0 again it is quite easy. 3 केला again it will be easy as compared to the, but जर सपोज मी 4 केला 5 केला तर काय होणार आहे ह्या दोन ह्या चॅनेल मधलं जे डिस्टन्स आहे याच्यातलं जे डिस्टन्स आहे ते मॅक्सिमम बिट्सने ऑकर होणार आहे आणि त्यामुळं ते बिट्स एकमेकांच्या सोबत क्रॅश होतील आणि ड्यू टू धिस एरर विल डेफिनेटली गेट ऑकर. Am I clear? So that is the reason if we increase the signal levels, error will get increased. Now also bit rate of a system increases with the increase in the number of signal levels we use to denote a symbol. Means bit rate means ज्या रेटनं बिट्स जाणार आहेत ते पण तुमचे इन्क्रीज होतील आणि त्याच्यामुळे अगेन एरर विल ऑकर. So that is the basic assumption or declaration by the Nyquist to decide the capacity formula. Now assuming all these conditions means the channel is noiseless, also if I increase the signal levels then error will be high. So assuming all these assumptions Nyquist has decided the capacity formula as C is equals to 2b log to the base 2 raised to n. This is the formula. Okay, now what is this formula? C is equals to 2b, that is nothing but the 2 into bandwidth. So why this 2b is given? So depending upon this whatever bandwidth is there maximum double of it data or the rate of the bit can be allowed to decide the capacity of the channel. राईट. सी सिंपल एक्झाम्पल एक लक्षात ठेवा फॉर द नायक्विस्ट. सपोज एक पाईप आहे आणि त्याच्यातून फ्लो होते वॉटर फ्लो होते. सो त्या पाईपची कपॅसिटी जेवढी आहे तेवढ्यानं त्या फोर्सनं जर वॉटर आलं पाणी आलं तर इझिली फ्लो होईल. बट जर खूप सारा फोर्स आहे तर काय होणार आहे पाईप क्रॅश होणार आहे, तुमचं पाणी जे आहे ते बाहेर पडेल. सिमिलरली जेवढी चॅनेलची कपॅसिटी आहे मॅक्सिमम तेवढाच डेटा कॅरी होऊ शकतो. जर त्याच्यापेक्षा जास्त तुम्ही डेटा कॅरी करायला लागला त्या चॅनेल मधनं तर एरर ऑकर होईल. सिंपल. अँड दिस इज द फॉर्म्युला. C is equals to 2b. Why 2b? Because जे काही तुमची बँडविड्थ असेल किंवा हे असेल चॅनेलचं कॅरी करायची कपॅसिटी असेल त्याच्यापेक्षा फक्त डबल मॅक्सिमम डबल बँडविड्थचा डेटा फक्त सेंड होईल. अँड दिस इज द फॉर्म्युला. सो सी इज द कॅपॅसिटी, B is the bandwidth which is measured in hertz, and N is equals to level of signal. Level of signal is this one. So this is the formula to decide the capacity of the tunnel for noiseless channel. If there is no noise available in a channel. This is the Nyquist formula. Now we'll see some of the example from which you will get understood. So first is what? Consider a noiseless channel with bandwidth of 3000 Hz. Bandwidth is what? 3000 Hz. Is transmitting a signal with two signal levels. Signalची level किती आहे? 2. The maximum bit rate can be calculated as. So maximum किती त्याचा data जाणार आहे? That is capacity or bit rate. So solution is what? C is equals to, or bit rate is equals to 2b log 2 to the 2 raised to n. 2 into b is given 3000 hertz into log to the base 2 raised to 2. This n is what? Signal level, that is given already 2. So if you solve this, you will get this answer 6000 bits per second. So maximum for this condition, maximum bits can be sent are 6000 per second. Am I clear? समजलंय? Note down this formula. You have to solve the other examples also. There are examples. Note down the formula for the capacity. C is equals to 2b log to the base 2 raised to n. This is the formula. So this is the example we have seen. Now solve this example. Yeah. Same example, same formula you have to use. Bandwidth is again 3000 Hertz, and now transmit signal levels are 4. Then what will be the capacity of a channel? Tell me the answer. Yeah, what is the answer? What is the answer? Akshata Kumbar, answer is wrong. Akshata Kumbar, wrong answer. Solve
Okay.
it again.
Yes.
Yeah, I'm not seeing the chat box. What is the problem? Omkar Sati, again a wrong answer. You are not solving properly. Prashant, how it came? 28, 8, 9, 8. It is wrong. It is very easy example. Write down the formula properly. Formula काय check करा आणि proper answers लिहा. Formula is 2, C is equals to 2b log to the base 2 raised to n. So what will be the case? 2 into 3000 into log to the base 2 into 2 raised to 4, and solve the answer and solve the example. Tell me the answer. No, Vishal. It is wrong. Sir, Vishal, then Vikas, it is wrong. Sneha, it is wrong. Abhay, it is wrong. No, it is wrong. How you are calculating? I don't know. Okay, question. This is the question. Wrong answer, Amruta. You are not solving properly. Solve it properly. Om Raj, Yogi Raj, Tanvi, Pratik. Solve it fast. I hope everyone is solving. Tanvi, wrong answer. Wrong answer, Shubham. How you are solving? Pawan, wrong answer. How to take log base 2? Rohit, wrong answer. How to take log base to the 2? You have a maths lecture now. You can ask your maths teacher. Everyone. I think you are not getting how to take log to the base 2. So it is today's exercise for you all. You have to learn all how to take log to the base 2. No one is solving properly. Rohit, 24,000. You are near to the answer. Somewhere you are missing. Calculate properly. Rohit Mori. Yeah, exactly. Pawan, correct answer.
Yes, ma'am.
Yes, how you have calculated log to the base 2? Can you please explain?
Ma'am, 4 into 2 raised to 2,
Sorry?
log 4.
Ha, log 4.
4 ला मग 2 raised to 2 केलं
Okay.
आणि 2 पॉवर असल्यामुळे 2 into log ते 1 होणार log 2.
Okay, log to the 2. Okay, fine. Your answer is correct. Answer is correct. 12,000 is the answer. Others, how to calculate log to the base 2? You have to learn. Okay, today it is your exercise. Today you have to learn, all of you, how to calculate this one. If you have understood whatever Pawan has said, you can calculate now only, now also. Omkar. Okay, calculate, or you can just first learn how to calculate it. And tomorrow or in next lecture again, I'll come with some examples. At that time, you have to solve it properly. So I'll show you the solution. This is the solution. So as you don't know how to calculate log to the base 2, first clear that thing, then you will get an answer. So 12,000 bits per second is an answer for this particular question. Okay, so there are some examples, but we will see in next lecture. I hope you will learn how to calculate this. So this is your today's exercise. Okay. Now, have you understood Shannon capacity formula? Actually, in your question paper, means till now, there is no, for university question paper, there is no question directly asked for solving this example. Example वरती question नहीं है. They have just asked the question as explain Nyquist capacity formula or Shannon capacity formula. But we should know how to calculate and that's why I have taken these examples. So next formula that we are going to see is the Shannon capacity formula. So this is the formula designed by considering that there is some noise available during the or in the channel. So that is the consideration made by the scientist Shannon. So Shannon capacity theorem gives the capacity of the system in presence of noise. Already I have told. And the formula for this is C is equals to B log to the base to 1 plus SNR. So this term SNR we have already seen. What is SNR? It is nothing but the signal to noise ratio. Why it is used to indicate or to decide the strength of the signal. So if SNR is noise is present, what will be the strain? If it is not present, what will with how much data can be sent? So that all things are decided and it is used in Shannon capacity formula. This one. So what is the formula? C is equals to B. B is bandwidth log to the base to 1 plus SNR, signal to noise ratio. Clear? So this is the formula. So let's see some of the examples how it is decided. So for example, from this example you will understood what is SNR and what this formula is. What is the example? Consider an extremely noisy channel in which the value of signal to noise ratio is almost zero. So signal to noise ratio is almost zero. That is, the noise is so strong that signal is faint. Means what they are saying that in a channel noise is so strong, that is channel is too noisy, and due to which signal is faint, means we will not get a data properly or we will not get any data, we can say, as the signal to noise ratio is zero. Now what will be the capacity of the channel for this case? Let's see. C is equals to B log to the base 2 1 plus SNR. SNR is 0. So log to the base 2 of 1, it is equals to 0. So it will come as a 0. Means capacity of channel is 0. It means that for any bandwidth, the channel cannot carry any data or signal. That is the conclusion. Capacity of channel is 0. म्हणजे काय असणार आहे की त्या चॅनेलची कपॅसिटी 0 असल्यामुळे त्या चॅनेल मधून कुठलाच डेटा बँडविड्थ त्याची कितीही असो, मॅक्सिमम कितीही असो, तरी सुद्धा कोणताही डेटा ट्रॅव्हल होऊ शकणार नाही, बिकॉज चॅनेल इज टू मच नॉइसी. So from this formula we have decided that whether the particular channel can carry my data or not. That is decided. Clear? So signal to noise ratio is 0. So what we can conclude here is that if signal to noise ratio is minimum, it means that channel is noisy. If it is high or if it is Greater than 0, it means that channel is not noisy. Means too much noise नसणार आहे channel मध्ये. Am I clear? So C is equals to 0. Capacity 0 आली चॅनेलची. म्हणजे काय 0 आहे म्हणजे तो चॅनेल काहीच ट्रॅव्हल करू शकत नाही. त्याच्यातून कोणताच डेटा जाऊ शकत नाही. डेटा जाऊ शकत नाही मीन्स त्याच्यामधून कोणताच सिग्नल जनरेट होऊ शकणार नाही. That is nothing but the conclusion for this particular case. Let's see one more example. Okay, I'll show you the solution also. So next example is what? We can calculate theoretical highest bit rate of a regular telephone line. That is only given. A telephone line normally has a bandwidth of 3000. The signal to noise ratio is 3162. What is the capacity of a channel? Now you can compare. In earlier example, signal to noise ratio is 0. At that time, capacity comes to 0. If it is minimum, then it means that there is too much noise available. Now, here signal to noise ratio is 3162. It means that we can have a chance of sending the data. Now, how it is calculated? See here, C is equals to same formula 3162 plus 1, 3163. The answer will come as a 11.62 and this one. This is the answer. It means that for this particular condition, the highest bit rate for this particular telephone line is 34.860 kbps or 34,860 bits per second. Means this channel can carry this much data for or every second. So what is the conclusion from these two is that, what is the conclusion? Signal to noise ratio, if signal to noise ratio is minimum, capacity of channel is also minimum. And if signal to noise ratio is higher, then capacity of channel is also higher. Remember. Am I clear? Yes or no?
Yes, ma'am.
समजलं
Yes.
काय? Okay, so these are the two formulas. In next lecture also we are going to see some of the examples. Up to that you have to learn how to calculate this log 2. Okay, so I hope you are getting all these things whatever we have seen today.
Yes, ma'am.
Any doubt in this?
No.
2 points we have seen. 2 points we have seen today. First one was the transmission impairments and second is the channel capacity. Both points are important today. Capacity of a channel. These 2 points we have seen today. Clear? Transmission impairments and capacity of a channel. Any doubt? No. Okay. So